Hello and welcome to this maths DVD. It's the first of its kind, apart from all the billions and millions on YouTube. This is the first with me and a whiteboard on the wall. Yep, marks everything. It's a pretty good whiteboard. So what we're going to be doing today, as I said, is logarithms. I'll take you through some of the rules of them and we'll show you how to apply them to some exam questions. So let me just write the thing so you know what we're on about. Logarithms. So obviously I'll be rubbing stuff off and going on to the next page, as you would say. And so if you need to, pause the video when you've got some time to look at the stuff. So the first rule we're going to look at, well, I'll just go through them all actually. This is the first one. So log of log in base A of n is equal to x. Yeah, that's right. Sorry to get the head there. And this is because a to the power x is n. And this just works for any equation that'll look like that, log equation. Yeah, so as you probably heard, this is the base. This is just the log of a number, so it could be 3. And we'll show here in a minute, and if next one of the next rules will be a power, but we've not got that, we've only got it here, so it's a power. And these A, Z could be anything, but that's just what I've given it. So the next one, log. Sorry, I was deciding which one to do next. A in base A is equal to 1. And this is because A to the 1 equals A. Now, as I said before, A could equal anything. So anything to the power of 1 is always itself. Which kind of leads me on to this next one. So A to the power, so log 1 in base A is equal to 0. And this is because A to the power of 0 equals 1. So anything to be 2,700,000,000, anything to the power of 1, 0 is 1, sorry. And then we've got xy in base A is log x in base A plus log y in base A. So if you think of it as timesing, it's adding. This might come as a surprise to some of you who've tried to follow on this pattern. Log of A x over y in base A is equal to, you probably guessed this, it's quite obvious, log x in base A of, take away log A in base what? Yeah, sorry, log y in base A. So there are the few rules. We'll go on to the next one. Sorry, I'm trying to move it so you can see. So we've got, as I said before about the power up here, so I'll just put it here. So n times log x in base A is equal to log x to the power n in base A. And now they're basically just moving that to there, or that to there. And this will come in very handily in some of the exam questions that we're going to do in a minute. So, we've got another one. So log a m equals log a n. Now, all of these so far, well actually, I'll state that in a minute. So all A is the same base, and these two are going to be the same base as well, you would have thought. So that means, if these are the same, and these are the same, the only things, if the answer are going to equal each other, m and n must be the same. And this can be very useful. It might not look useful, but some equations where you're left with 2 and you think, what should I do? You can always simplify it down and just get rid of the logs. And then we've got this other one here, which I said about the bases before. So, say you've got an equation here. So log b in base A Just keep it nice and simple for you. Distinguish it a bit from the rest. Log C, log B and base C, log A and base C. Right, now you're probably thinking, well, what's C? Well, C is the base. As I said, for each one of these, A is the base, we've just given C the base instead. This one is particularly useful because it's for changing bases. Now, if some equations, as I said before, it's not necessarily given that they're going to be in the same base. So you might need to transfer it to bases. Now these C, it could be anything you wanted to. Obviously, you're not going to want to change it to anything different than the other base, otherwise you might as well not do that. So if one of them say log, well actually I'll give that equation just after I've rubbed all these out, but that's just how you, so obviously the base goes on the bottom of that one, and the what it log of goes on the top, and the C is just a chosen base. As I said, you can switch it to any base. Just a few things before we start as well. Sometimes you don't see this A as a given number, but you're left to assume that the log of anything that is unscripted is 10, sorry. And then certain things we're going to go on to, such as inequalities. When you've got a log that is less than 1, you might think, well, that's still positive, so why do we need to change the sign if we're dividing it down? Well, if you put log of 1 into your calculator, then it comes up as negative, so that's why you change the sign, because you can't have a negative log. So as I said before, yeah, that's the equations. So you could go back and pause to that and go over them equations, but they're really the main ones you need to know about. When I said main ones, so it implies there's 1 or 2 extra. Well, there's actually 1 extra to be precise. So if we go into, say we've got 5x equals 13, you think, that's not an easy one. You can't go it's 5 squared because that's 25, or 5 to the 1 because that'd be 5. So we need logarithms for this. And there's none of them rules that we've talked about seem to apply apart from possibly one of the first rules that we went over. So log A, x in base A equals, because of A to the power of x equals n. Or, well actually we're going to be using this one as well, but it's not going to be the one we're going to start with. So log A to the, yeah, sorry, that's the one we're going to start with. The first rule we're going to encounter anyway. What we need to do is we need to log both sides. So log, might sound fancy, but all you do is put the word log on each side. 5 to the x equals log 13. Now we've got a power here, which is x. As we said, we can move this to the front to get that. So that's what we're going to do for this one. So x log 5 equals log 13. As I said, we're not doing anything with this one at the moment, which is what we're going to come on to now. So basically what this equation is saying is x times log 5. Good if I could do maths and I'm teaching a maths video, and that would help immensely. So we've got x times log 5 equals log 13. We need to know what x is. So the sensible thing to do would be get rid of log 5. And you could do that by dividing it by log 5. So obviously x doesn't go into log 5, so log 5 over log 5 equals, well, it probably would, but we don't know what x is. Let's try to find out. Log 13 over log 5. And then this simplifies down. So x is equal to log 13 over log 5. And that is the simple bit of logs. So that's what you put. You put that into your calculator, you get a value for x. And sometimes it might say x is less than 6, so it has to be obviously less than 6, and that's quite obvious, that really. That's the basic rule of logs. I'm just going to pause the video for myself so I can get some more questions up for you.